Good morning, my friends and followers. This morning we are going to be discussing cointegrating relationship or relationships among time series data or panel data studies. So historically, the concept cointegration was first put in place by the work of Engle Granger in 1981, but it was popularized by the developments of Philip in 1987, Stock and Yo in 1986, Engel and Yo in 1987, Johansen in 1988, Johansen and Joslos in 1991, Johansen and Joslos in 1995. So these are the first players in the concept of cointegrating relationship or relationships among time series or panel data studies. So the term cointegration or cointegrating relationship means that two variables are stable or that they move in the same direction. It is the ability of two variables to move simultaneously that determines their level of cointegration. And when there is cointegrating relationship or a long-run association among two or three variables or more, it then means that there will be a convergence among them, or there is a convergence among them existing at the present. So cointegrating relationship in time series study means that the situation or the linear combination of the particular relationship is stationary. And when the level of stationarity of the linear combination of the series is caused by one variable alone, it then means that it is a one-way or what they call unidirectional causality or relationship in the study. On the other hand, when the relationship is being affected by the two persons at the same time, then we may say that there are two or more cointegrating relationships among the variables or the persons involved. Okay, there are many forms or types of cointegrating relationships, but we are going to dwell on six types or forms of cointegrating relationship, three from time series studies and three from panel data study. But for the ease of time in this particular study, we are going to make emphasis on Engle Granger procedure alone, and we'll also go to eView. I will go to eView to teach you how Engle Granger procedure is being estimated using the eView. So there are many types of cointegrating relationship. We have the Engle Granger procedure, we have the Johansen cointegration text, we have the Bonds cointegration text. Those are time series studies. We also have the Cow cointegration, we have the Pedroni, we also have the Fisher. Engle Granger in 1981 came up or was motivated to the concept of cointegration due to his inquest to actually look at linear relationship among time series study. And he identified that the relationship between the stationary time series study and their long-run association was something that every scholar actually need to look at, because he envisaged that most of the time time series data are stationary, and some of the time they are also not stationary. Remember, I taught you, or I told you the other time, that time series data are always stochastic in nature, and given their stochastic disposition, it is expected that they most of the time behave in a manner that is not stationary. So given that situation, Engle Granger came up with the fact that a stationary time series data at level can also be modeled with a stationary time series data after first differentiation. That implies that you can be able to combine the linear relationship between a variable that is stationary after first differentiation as well as a variable that became stationary at level. It is on that premise that the Engle Granger procedure was built, because Engle Granger believed that the dependent variable must be stationary after first differentiation, while the independent variable must be stationary at level. What do I mean? The dependent variable is the variable at the left hand side in an ordinary least square equation, which is also always represented with the subscript y, while the independent variable is always at the right hand side, is also called the explanatory variable. So Engle Granger believed that for you to perform a Engle Granger procedure or cointegration, you must be working with a single equation model which has two variables, one dependent and another independent. And the condition is that the dependent variable must be I1 while the independent variable must be I0. These are the only conditions that will make you to actually want to perform your Engle Granger cointegration test. So the steps or procedures required for Engle Granger test is that first, you need to test the stationarity condition of the time series data to actually know if they are integrated at order 0 or 1. Provided you are able to test and confirm that that particular condition is being upheld, then you can now actually look at for the second condition. The second condition is to test or to check the Watson statistics. Me and you know that I taught you the other time that for you to actually check the sporosity of a time series study, you should actually look at the value of the Watson statistics. That whenever time the Watson statistics or the value of the Watson statistics is less than the value of the adjusted arrow square, that means there is an evidence of first order autocorrelation, which is a suspicion that the regression result may be spurious anyway. But this particular statement is probabilistic. It may be or it may not. The fact that the Watson statistics is lower than its expected 1.5 and 2.5 range doesn't mean that that regression is spurious. For you to actually conclude that the regression is spurious, you need to subject the residual of that particular estimation to a unit root procedure that will actually validate or invalidate your hypothesis. So to look at it, the next thing is to actually subject the new variable you are going to generate to a time series, to a stationarity test, and to actually look at the behavior of the time series data, the new Engle Granger variable, for you to actually conclude that there is cointegration or there is no cointegration. So basically, the limitation of the Engle Granger procedure is that one, it is difficulties in separating the dependent and independent variables in most of the time in Engle Granger procedure, and the cointegrating equation is based on one cointegrating relationship. It can't incorporate more than two independent variables in Engle Granger procedure. And thirdly, it relies on only two steps estimation procedure, and that is what we know about the Engle Granger procedure. It only uses two variables, and while introducing another variable, it becomes very, very spurious. So now let's go to eView. Let me teach you how you can be able to perform the Engle Granger procedure using the eView. So this is my eView worksheet. I've already opened it. Assuming that we are adopting a study approach where we look at the impact of inflation on unemployment. Let's look at how interest rate affects unemployment in Nigeria. If this is my interest rate variable, this is my interest rate variable, and I want to look at how interest rate affects unemployment. This is my unemployment series. Then if I actually want to look at it, the first thing I'm supposed to do is to go to quick. Let me assume that this unemployment series became stationary after first difference, and the interest rate variable was stationary at level. That means that unemployment is I1, the interest rate is I0. Then the next thing I will do is to go to quick, maneuver to equation estimate. Then you estimate your equation. Remember, it's just a single equation model, so you don't need to estimate or to input much, only two, one dependent. This is the dependent one at the left hand side, the y. This is the independent one at the right hand side, the x. So we have the y equal to x. Then without changing anything in this particular portal, you click OK. If you click OK, you are exposed to a result that looks like this. A result that looks like this. My sample size okay, I will look at it later. A result that looks like this. So in this result we have a dependent variable and the independent variable. The independent variable is interest rate. The dependent variable is unemployment. Let me reshape. Okay, unemployment. The W-Watson statistics is 1.092, and the F statistics and others are this. But the problem is the R square and its R square adjusted, they are very, very low. If you look at the W-Watson statistics, it's far higher than the R square and the R square adjusted. So actually, for me to proceed with the Engle Granger procedure, I will need to actually subject the residual of the time series data into a unit truth procedure that actually will be okay for me. So given the fact that I have already known the time series, the behavior of the result, the next thing to be done is to actually generate the Engle Granger variable. The Engle Granger variable will be generated. There are too many ways you can use the coding method, but I actually prefer students to go through this particular button here, the generate series button. If you click on the generate series button, you now say that Engle Granger equal to residual. You are asking the EView to give you a new variable called EG or EG. EG is the subscript for Engle Granger, and this EG now is a new variable. The value of this EG will be the same with the value of the residual. If you open this EG, you see the same value. It has gotten a value, and the value is the same value with what we have as the residual previously. This is our residual. So this is our residual. So for me to proceed, the next thing to be done is to subject the new variable, this particular residual that is now converted to EG into a unit truth procedure. If you go to view, you click unit truth, you leave everything as it is or the way, you click OK. You have gotten a unit truth result that actually can be interpreted and looked into. This is the dependent variable, and the null hypothesis is that EG has a unit truth, while the alternative hypothesis is that EG do not have a unit truth. And given the fact that the T statistics is above the critical value at 5% in absolute term, and the P value is significant, we now conclude that yes, there is no unit truth problem in the EG variable. That means that the null hypothesis is rejected and the alternative hypothesis is accepted. The EG variable do not have a unit truth text. And what is the implication of this? This now implies that the original equation, the original position of the W-Watson statistics that shows the presence of spurious regression will actually be rejected, because with this result we have now been able to actually conclude that our original equation is not spurious. Our original equation is okay. Then we need to actually interpret it and work in line with how it's supposed to be. This is our original equation. The original equation we actually modeled previously. This is our original equation, if I'm not mistaken. This is what we looked at before. This means that there is no issue of spurosity in this regression, despite the behavior of the R square and the R square adjusted. If you look at, as well as the W-Watson statistics, so despite this, we cannot say that this particular regression is okay, and it also can be used for any meaningful interpretation. But had it been the new variable EG wasn't stationary at level, we will not subject it to a first order stationarity condition to enable us include it and remodel in this particular equation again by including the new variable as one of the explanatory variables in this model, and at that level we can now get a new result that we actually going to be called the completion of the Engle Granger procedure. But in this regard, this new variable is not necessary because it was stationary at that level. the Engle Granger procedure is existing. We can now conclude at 10%, interest rate cointegrate with the unemployment at 10%. But at 5%, there is no cointegrating relationship between interest rate and unemployment. At 1%, there is no cointegration. But in economics, our attention is on 5% because we are interested in actually looking at 95% level of accuracy. So if I may also look at it from that point of view, we can now conclude that there is no cointegrating relationship between unemployment and interest rate in Nigeria, and that is what we actually want to talk about today. And that is the end of that procedure called Engle Granger procedure, and we have come to the end of it. Please stay tuned to this channel. In the next class, we are going to be talking about Johansen cointegration test, where we are going to talk about what happened to the max aging statistics and what happened to the trade statistics, and also bring what we call the junk box. It's going to be an interesting section. Thank you and God bless you.